In this video, you will learn to describe the three encryption types used in modern cryptography, including typical uses and advantages of each: symmetric, asymmetric, hash.
On this section, we'll discuss three main types of cryptography or modern encryption types. They're the symmetric, the asymmetric, and the hash functions. Symmetric encryption, there are several pros of it or strengths. Those include the speed and the fact that the cryptographic strain increases by beat of the key. So meaning, if we have a bigger key, the cryptographic will be more secure. The problem with symmetric encryption is that the key needs to be shared using a secure method, sometimes an out-of-band method, meaning we cannot send the key in plain text to the third party using an unsecured channel. Because as we discussed previously, the whole restraint or the encryption algorithm or the algorithm is based on just one key, and that key needs to remain secret at all times. DES, triple DES, and AES are just some of the examples that we currently use, and AES is one of the most modern symmetric encryptions that we currently use as of today. On the other hand, asymmetric encryption uses two keys. Whitfield Diffie and Martin Hellman are the ones that created the Diffie-Hellman algorithm. They're considered the pioneers of the modern asymmetric encryption. On a asymmetric encryption, we have two keys, as I mentioned before. One key can be made publicly, called public key, and the other one needs to be kept private at all times. This is called the private key. Since we have two keys, one key is used to encrypt and the other one is used to decrypt. So basically, whatever is encrypted with the public key can only be decrypted with the private key, and the other way around as well. Whatever is encrypted with the private key can only be decrypted with the public key. Asymmetric encryption is used in digital certificates. It's used in the public key infrastructures. It uses the one-way algorithm to generate the two keys. It's based on math, like factoring prime numbers and discrete logarithm. This is basically used for generating the two set of keys. It's actually a lot slower than symmetric encryption, and this is a reason why whenever we use asymmetric encryption, most of the time we're using symmetric encryption as well. To put in an example, whenever you visit a website, a HTTPS website or a secure website, you're using asymmetric encryption first to exchange the key for the symmetric encryption to be used from that point forward. So basically, as we discussed earlier, since we need to be able to exchange the key for the symmetric encryption in a secure manner, asymmetric encryption permits that we exchange one key between two nodes or two parties, and from that point forward, we'll be able to use symmetric encryption, which is a lot faster in a secure manner. The hash functions provide encryption using a one-way algorithm and no key. This means that any length or a variable length plain text is hashed into a fixed length hash value. This is often called a message digest or simply a hash. This is used, like we talked before, for integrity. If a message or a plain text changes, and we can determine this by hashing that same plain text and checking the previous hash and the hash that we just did. In other words, if we generated a plain text and we send it to somebody else with the corresponding hash, and somebody changed that plain text in transit, then we can determine if something changed on that message using the previous hash generated and then the hash generated after the message arrived. SHA-1 and MD5 are older algorithms. They are prone to collisions, and SHA-2 is the newer and recommended alternative. Hash functions are prone to collisions, or that's one of the issues. SHA-1 and MD5s are the algorithms, older algorithms that are more prone to collisions. A collision means two different plain texts having the same hash at the end. Since we have a limited amount of characters that the hash actually outputs, let's say MD5 outputs 15 characters or more, there's a possibility that two plain texts can have the same exact hash value or message digest. Those are called collisions.